Yes, so good morning. Okay, so in our last lesson we talked about clustering and described what clustering is, looked at the components of clustering. Essentially, just to recap, when we cluster our gateway, what we are doing is we are completely duplicating all the functions of the gateway, including the session tables, the VPNs, all of the states, all the interfaces, and essentially we're keeping a mirror image of that device, so that if one of the devices fails, then the other one will simply take over the functions or the gateway functions. We also discovered that when we're clustering, we can configure our devices so that we have the forwarding planes of both our devices being active. In other words, we are sending traffic to the forwarding plane of both devices. However, only one of the devices can be the primary control plane, or really the plane where we will go in to make configuration changes. So one of the devices will be the primary for control plane and configuration changes, and those configuration changes will be duplicated across onto the secondary device. So we configure one, and those changes are duplicated across. So let's get into now. The other thing we discovered is that there is a change to our interface naming scheme. So in a single device, of course, we have our standard interface naming schemes, whereas in the new device, we have a thing called REIT interfaces, which are redundant Ethernet interfaces. So we're going to be changing that configuration naming scheme to those new interfaces. So let's just go in and now take a look at what's involved in setting up a cluster. And at the end of this section, I'm going to take you through a scenario where you have to transition from a single device to a cluster. So there are some things you need to think about when we're doing that process. The best approach to clustering is to start from the beginning with a cluster. So when you're designing a network, really the best thing is to say, from day one, we're going to have a cluster. You set it up and then you configure it from there. But we can transition, because that obviously, that doesn't always happen. Okay, so we're going to take a look today at describing the chassis cluster operation, configuring chassis clusters, and monitoring chassis clusters. So let's get into the operation. Okay, so the first one boots up. Right, first one boots up, and the one that boots up first becomes the primary. It becomes the primary device as far as the control plane goes. And the second one boots up will become the second device. Okay, so we go back and look at this here. So the first chassis to boot forms the cluster that the routing group transitions from the blank state to the primary state. So when the second one boots up, the RG of the second chassis transitions from the blank state to the secondary state. So this is routing group 0. Routing group 0 relates to the cluster itself, and the configurations will then synchronize. So leaving a cluster, if you have to leave a cluster, then the leave action can happen when the chassis reboots or powers off. The leave action can cause the RG state to change from secondary to primary. If one of the devices shuts down, then there'll be a change of state. let's look at a situation where you can get a cluster split. Now you don't want a cluster split. A cluster split is a bad thing, but it can happen when the control or a data link failure causes the secondary node to enter into the disabled state, or simultaneous FXP1 and the fab link failures result in a split. So you really have to have these multiple failures to create a split. Two clusters can merge into a single cluster. Requires a reboot of the disabled or altered cluster. So we can pull a device out of one and put it into another cluster. So let's look at the active-passive mode. So active-passive, we've got node 0 being the active. We've got the active sessions running on that. We've got backup sessions running on the other node. We can also have the active mode, where we are in fact using the forwarding plane of both devices to forward traffic, and we have traffic may need to transition from one device across to the other in order for that to happen. But we've got a link already in place for that to occur, so that's part of the clustering configuration, is to provide for our forwarding link. So we've got our switch fabric forwarding link in place for switching traffic. Okay, so we can have active mode. Now we're talking about the forwarding planes there in active. So let's take a look at how to deploy that. So essentially it's the active-passive mode done twice, but you do it on each node. We have a data forwarding path which links the two together, so that if data has to transition between the devices, it will go across the data path. And we have a health check for the secondary node in place. So let's take a look at the configuration. So first up, physically connect the two devices. Now, we already said earlier that last lesson, they need to be the same model. So really, what you really want to do is get two identical devices. Any two Ethernet interfaces, one per node, of the same media type to create the fabric link. If you're using a high-end device, it's going to be a fiber connection, or a branch device, Ethernet, Cat5, Cat6 is fine. Connect the control ports to create the control link. On the high-end devices, you'll use these SBC slots. On the low-end devices, the branch devices, you'll just use a regular Ethernet interface. And on the high-end platforms, you configure the SBC control ports. Enable clustering, you'll set up the cluster ID and node ID for each device, reboot the primary device, and then reboot the secondary device. Okay, so enabling the cluster, we are coming up under the edit chassis cluster, and we're setting up the control ports. So if you're using these FBC slots and ports, you'll set those up under there. That's on the high-end platforms. You need to configure those slots and those ports under your cluster configuration. And the configuration for enabling the cluster is set chassis cluster ID, node ID, and then reboot. Okay, now if you need to disable the chassis cluster, then essentially you're going to go in and delete the chassis cluster. Get rid of that and then reboot. Sometimes you will need to delete that. Sometimes you'll find that you'll get a device. Maybe you've got one that's been used before and it's been part of the cluster, and you want to use it separately. So in that case, you'll have to delete the cluster. On the second node, you're going into set chassis cluster ID and node ID, which is, of course, you're going to have the other node ID. So there's only node 0 and node 1. So the primary will be node 0, the secondary will be node 1. And we'll reboot that one. When it comes up, your cluster should have formed. You need to configure your management interfaces of your devices. So you'll put a different IP address on each of your management interfaces. You need to configure your fabric interfaces, redundancy groups, redundant Ethernet interfaces, physical interface renaming for a secondary node. Now what happens here, just on this point, is that let's just say we've got 2 small branch devices. They've each got 8 interfaces. So, and of course the physical interface numbering scheme on each device starts with, just to say we've got 8 gigabit Ethernet interfaces for argument's sake. You'll have GE 0/0/0 through to GE 0/0/7. That will be the naming scheme on both devices. When you go to a cluster, what you find is that the primary device will retain its interface naming scheme, so 0/0/0 through to 0/0/7. However, the secondary device will begin its interface naming scheme at 0/0/8 and go through to 0/0/15. Okay, so you'll actually continue the interface naming scheme from the primary device. So when you go and look at your secondary device, your interface naming scheme has changed on the secondary node. Okay, and you have to go back and configure your cluster failover parameters. So here's a look at the configuring the primary node. We're going to go under the edit groups hierarchy. We're going to go under system host name. So we're going to give the host name a unique name. So you'll often call it primary or secondary, depending on how you wanted to set that up. Interfaces, so we're setting up a unique IP address on the FXP 0 interface. And then you've got your node 1. So under your groups, you'll notice you've got a subheading of node 0 with this configuration, and then you've got node 1 with its configuration. So it'll have a different host name to what you've got up here under node 0. And then you've got a unique IP address down here for node 1. Now you're configuring all of this on your primary node. So all that's being configured on the primary node. So just notice we're going under the edit groups hierarchy. Is where this is all happening. And you notice it's happening on node 0, which is our primary node with our active control plane. Okay, one of the things we need to do, you'll notice here under the primary node is set apply groups over there, and that will ensure the group assignment on both nodes. Okay, so under the interfaces, we've got a Fab0, we've got a Fab1. So we've got the interface from node 0 and the interface from node 1 and the interface names. Okay, so these are our interfaces, our fabric interfaces that we're now setting up. Under the this is the show chassis cluster. We should see our nodes 0 or 1, and you should see the priority of those nodes. And set the priorities. This has got a preempt here. If you leave that out, then what will happen is if the priority changes, you can set up priorities. The priority is going to affect which one becomes the primary, which one becomes the secondary. The preempt parameter means that if we change our priorities so that what is currently a secondary has a higher priority, then the devices will switch. So our primary and secondary will switch, will have a failover. If you leave out the preempt parameter, then that will not occur. Also setting up our interface monitoring, name, and the weight assignments for each interface. Okay, so configuring our redundant Ethernet interfaces. We've got our show interfaces, gig ether options, redundant parent. So we've got the name of the interface there, a REIT number, and we've got the same down here on the other. So we've got REIT number, redundant Ethernet options, unit 0, and an IP address. So we've got the interface is actually known as a REIT interface. So we're actually configuring, you configure multiple logical units just as you can on a regular interface. So all those things sort of apply. You can see that the child interfaces have got the GE names as usual, and all we're really doing there is we're setting up which or which child interfaces are attached to which REIT interfaces. That's really what that configuration is about. So the redundant REIT parent is configured on the child interfaces, and then all the other configuration which you would regularly put on an interface is done on the REIT. So you've got your IP address and then the other configuration on that particular interface. Cluster failover parameters. We can take a look at our heartbeat interval, set that up, interval of time between the heartbeat messages that broadcast to all nodes in the cluster, set up a threshold, how many missed heartbeats that must be exceeded to declare the other node is dead and therefore trigger a failover. So that is under the chassis cluster hierarchy. Disabling the chassis cluster. Now this here is done not in configuration mode, but it's done in operational mode. Set chassis cluster disable. Is the command. So it's a set statement, but we're not in configuration mode. We're actually in operational mode. And monitoring the operation of the cluster. Here's a network diagram. So prior to issuing the cluster forming command, we've got our two devices there. I will actually go through the process of forming a cluster shortly, so I'll go through that in detail. Some steps you would need to follow. Okay, so we've got a couple of devices physically connected, and forming a cluster. On the host 1, we're going to take a look at the ports that we've got set up as our control ports with our set chassis cluster ID 1, node 1, node 0 reboot, which is the primary, and the secondary is set chassis cluster ID 1, node 1. And then reboot will enable both of those clusters. Okay, one of the things that changes is you notice the interface naming scheme. Let's go back and look at that naming scheme again. You'll notice here that on this device we've got GE100 and GE100 on the other device. So host 1 and host 2 have got interface names. So coming back into our on to add to our Ethernet 100 and 100. Going back into our internal network, we've got 000 and 000 on both. After the cluster formation, you'll notice that their names have changed. So we're coming up on the node 1, sorry, node 0 is identical, but node 1, the interface names actually are contiguous and continue on from where node 0 leaves off. Okay, so we're coming up with 12 and 13 on node 1. And show chassis cluster status. On node 1, we'll come up with which one's primary, which one's secondary. And take a look at our show interface terms. We're looking at FAB and FXP1, and take a look at those interfaces. And make sure that they're okay. Configuring the management interface, we had a look at this earlier on. This is done under the edit groups hierarchy. We've got a management interface for node 0 and a management interface for node 1. They have got unique IP addresses on them. So you can actually connect and manage each of them individually, although when you are configuring your cluster, you will be going into node 0 and put your configurations on node 0. These are fabric interfaces, Fab 0, Fab 1. Looking at the member interfaces on those fabrics. Remember, the interface names do change, so that you have to go in and make sure you've allocated those member interfaces. Looking at the redundancy group. So after you've got your cluster up, you will go and then set up your redundancy groups. This is an example of setting up redundancy group 1 here. The purpose of setting up redundancy groups in a cluster is that you will associate interfaces with a redundancy group, and that allows you to then monitor those interfaces. And then if an interface fails, then there'll be a failover to the other redundancy group. So what you do is, on each node, you set up redundancy groups where one is primary on one node and the other is primary on the other node. But that allows you to achieve an active-active field plane. Take a look at our cluster status. Configuring our wreath interfaces, have a look at that, where we're going on to the physical interfaces and defining what the parent wreath is. Then you actually go on to the wreath interface itself, and you're going to put your configuration onto that wreath interface. So whatever regular configuration that you would normally put onto a physical interface, you can put onto the wreath interface. Take a look at that. Go and look at our show chassis cluster. We'll take a look at the half-bit interval and the threshold. And we look at our stats there. So let's look at the manual failover. Show chassis cluster status redundancy group 1. So we're taking a look at redundancy group 1. We've got node 0 being the primary and node 1 being the secondary. And we can initiate a failover manually with the request chassis cluster failover redundancy group 1, node 1, and that will then fail over to the other, where we now have node 1 being the primary, 0 being the secondary. Okay, so you can initiate that just to make sure that it works. It's just testing that you can fail over, and reset the failover. You can reset the failover. Unless we've got preempt configured, it's not going to automatically revert back. If you want that to happen, you need to put the preempt configuration under the chassis cluster hierarchy. Take a look at our log contents, which is the JS RPD, and we can take a look at the status of our cluster and cluster events, and we can also put trace options onto our cluster. Take a look at that. Okay, so we're going to look at the cluster operation, how to configure a cluster, and monitoring clusters. Let's take a look at some review questions. I then want to go and just go through a step-by-step scenario of converting from a single device to a cluster device. What's the difference between active-active and active-passive mode? So what do we mean by active-active? What do we mean by active-passive? What does that actually refer to in a cluster? Active-active versus active-passive. So what would active-passive be? One device is forwarding traffic, the other device is doing nothing. It's just waiting there in case the first one fails. Active-active is both devices are forwarding traffic. So what log file contains chassis cluster related events? Okay, let's go back and cheat. And there it is, the JSRPD log file. Okay, what command can you use to examine the status of a read interface and its child interfaces? Okay, if we just go and take a look at our show interfaces, just go back and look at that. We want back into our show interfaces, there we are. So we're looking at show interfaces, and we can see we've got reef and the child interfaces that relate to that reef. So there's two child interfaces, GE 000 and 1200, and then we've got reef 1. Okay. All right, so what I want to do is jump out to the end of that there. Okay, so what I wanted to do is just go through a step-by-step on how to actually change from a single device to a cluster device. So I've just got a list of steps up here that I have configured. Behave itself. Okay. Okay, so this will work for me. Okay, let me see if I can get this to zoom up. I think I'm stuck with that for now. So let's go like that. Okay, so let's just if I can. That's better. Better. Okay, so let's just go through the steps. So here we are. Let's just say we've got a single device, and we decide that we need to have a cluster. So of course we're going to buy our second device, make sure that it's exactly the same as the first one. That's why it's kind of better to plan this from the start, because maybe your second device is an older device and it's difficult to get exactly the same device. The original device is an older device. Okay, so plan the cluster setup. Everything starts with planning, so we're going to plan our redundancy groups and our RIF interfaces and child interfaces. So how are we going to configure it up? So just sort of plan it out. These are the interfaces that I'm going to need. These are going to be my child interfaces that I'm going to use for those RIF interfaces. Then you're going to save your current configuration on the original device. Just save it up to an FTP server. You're going to need that because we're going to go into our next step and modify the current configuration to replace the current interfaces with the new cluster interfaces, which are going to be these RIF interfaces here. Okay, so your existing configuration won't work. You can't just bang it back onto your cluster because your interface names are going to have changed. So you're going to be putting that configuration that you currently have onto RIF interfaces, not your original physical interfaces. Right? Because we're going to create these new RIF interfaces. So your actual configuration will then go onto those interfaces. So you're going to have to modify, you're going to take, so basically you're going to have to save your configuration, open it up in a text editor, and go in and change the interface names on that configuration. So you're doing it offline. You're doing offline modification. It's a fairly simple process. You can simply find it in place. It really is that simple. Once you know once you've planned it out and know what your RIF interfaces are going to be in your cluster and where they're going to be in the configuration, you simply just can do a find it in place on your configuration and change that. So every reference of that interface needs to be replaced. So this is going to be, of course, in the interfaces hierarchy, it's going to be in the zones hierarchy as well. You need to change it everywhere. Now, if possible, test the modified configuration in a virtual environment. Now, it is possible. I want to say is possible. It actually is possible. Juniper have virtualized versions of the SRX devices which run in VMware, and it's also run in a Linux KVM scenario as well. So virtualized environment runs in Linux. So they have devices which are suited for or designed for either environment or each environment, and if you get the appropriate device, you can just run up a cluster in VMware, for example, and just see that it works. Okay, test it all out. That's a nice thing to do. What you will test is that your configuration actually loads. Okay, that's probably what you're wanting. Loads properly and works. Okay, so now that you've got a modified configuration, you need to arrange for a planned network outage. Why is that? Because you're going to have to take the operational SRX offline for this to happen. Yeah, right. Okay, so this we're assuming this is operating as a gateway. All right. There's a couple of reasons for that. First of all, when you go to build your cluster, we're going to have to configure the interfaces, the physical interfaces, for the cluster interface. So we're going to have to set up specific physical interface connections which are required for our cluster. So we're going to be unplugging stuff, unplugging cables and whatnot. So the other thing is, there's a few reasons for it. Let's just go through the next step here. You raise the current configuration. You can leave the system section there if you like with the name or actually a few system parameters, but probably better off just get rid of the lot. It's the easiest way to go. Now you have to put the device into packet forwarding mode. Now, the reason I say that is because this device is gateway. Right? This device is operating as a stateful firewall. It's not in packet forwarding mode, it's in flow mode. Now, if it's in flow mode and we're wiping the configuration, what we want to achieve next is we're going to be connecting our new device to our existing device And we need to get communication across those cluster interfaces. So we've got the fabric links, we've got the FXP1 links, we've got our switching fabric link, we've got all those links that need to be communicating and get communication across those links to form the cluster. Well, if we are in flow mode, there's going to be zero communication across those links. Why is that? Because all of the interfaces will be in the null zone. Remember, we're in flow mode, we have this zone called the null zone. And everything that's in the null zone will not pass traffic. Right, so we cannot form a cluster while we are in flow mode. All right, you've got to change it in flow mode into forwarding mode. And there's a command for that. So basically, you go into your configuration and change it. Okay, you then have to do a reboot. You probably have to do it on the second device as well, because the factory default configuration that you will have to, the factory default configuration for a Juniper SRX is that it is in flow mode. So you probably have to go into there and you have to wipe its configuration and change it into flow mode. The reason I say wipe the configuration is because as long as you've got your security configuration there in place, you can't change it to mode. You've got to get rid of that. And at the same time, while you're getting rid of that, issue the command to change it into packet forwarding mode. Then you'll have to do a reboot. So as soon as you change your mode, you're going to have to do a reboot. You're forced to do a reboot as soon as you commit to configuration. So you'll get a message coming up saying, okay, you've changed the mode, now need to reboot. So you get both of your devices have to be in packet mode when you form this cluster. Okay, if they're in flow mode, you won't form. Okay, now we're going to physically connect the second device, have it all nicely set up in our rack, everything powered up, nicely connected. Then we're going to go and configure our cluster components. So this is where we go in and we're going to configure our nodes. So we go into our groups, node 0, node 1, set up our management addresses. We're going to go in and set up our cluster interfaces underneath there. We're going to set our cluster ID and node ID. All that's going to be set up. Go in, reboot. You may need to go ahead and, after this, go and set up some additional cluster components as well after you've rebooted. Okay, so what we're focusing on here is really just setting up the cluster components. Set up your thresholds, set up those various aspects that relate to the cluster itself. Okay, so once you've got our cluster set up, or our cluster components set up, then we want to take our modified configuration and we're going to load that onto the primary device. And we're going to use the load merge command. Now, in our labs, we've predominantly used the load override. We've loaded the configuration, we've used load override. The load override basically wipes everything that's there with whatever is in the configuration that you're loading, so it erases everything. We don't want to do that. What we want to do is leave all of our cluster configuration in place. So our cluster is set up, it's working. We'll leave that there. We're going to use load merge. So we're going to take our modified configuration, which references our new wreath interfaces, which we now have created in our cluster. Got all that set up now. So we've created those, and now we're going to merge that configuration into our cluster, and it will then load up and configure our zones. It will actually, this configuration will actually implement flow mode as well. So it will go from packet forward mode into flow mode as part of that configuration loading. You'll put in the zones, you put in your policies will come across. If you've got VPNs, that will come across. Everything will come across. Okay, so you load that in, and then you will need to reboot both devices, because when you change from packet mode to flow mode, you will reboot. and then they'll both come up in flow mode. So what that should have done is now has taken all of your original configuration that you had running on your single device and implemented that into your cluster. You now have an operating cluster. Okay, so one of the traps that you can fall into in trying to build a cluster is that you leave your devices in flow mode and then try and form your cluster while they're in flow mode. They just won't form because you end up with all your interfaces in the null zone and no traffic is going anywhere at that point. Okay, so you do need to get it into packet mode. Form your cluster, load your config, bang, switch it back into flow mode, happy days. It is working. Okay. Okay, so a bit of a process there. Okay, you can't just wander in. Let's hook up the other device and say become a cluster. No, that won't work. Okay, it won't work for a whole range of reasons. In that you can't even form a cluster while you're in flow mode, and also your interfaces have all changed their names because they're now wreath interfaces rather than physical interfaces. That's obviously won't work. So basically the story is get your configuration, save it, modify it, get in, build your cluster, make sure your cluster's working, configure up your wreath interfaces, configure everything up in your cluster. All your cluster stuff is done, and then just load your configuration back onto your cluster, referencing all of your interfaces, and you should be up and running. Okay, simple. Not really. It's a little bit of a job actually. Creating clusters, it's a bit of a job, a bit of planning. You've really got to think about how your network's going to function as a cluster. You've got to think about all the different redundancies that you may want to put in place in your cluster. Okay, so a bit of planning there. Alrighty, so that's basically the process for clustering. So we've had a look at what's in a cluster. We've had a look at configuring a cluster, and we've just gone kind of through a bit of a step-by-step process for going from single to multiple, or single device to cluster device. Okay, so what I'll do there, we'll just take a short break. We're going to get into our next topic after the break. We're going to be talking about unified threat management, which is antivirus, anti-spam, content filtering, all those sorts of issues that we may be interested in protecting ourselves against, or setting up our devices to regulate the traffic and regulate access to various websites and various content. So we'll take a quick break and we'll come back and look at that.